All right, let's
All
have
right.
a look at this. I like this page right here. You
Cool.
can do this page. You can probably do anything related to quadratics.
Cool.
Almost.
Okay.
So let me blow this thing up enough that we can see the points on this curve.
Okay.
And let's start with the first one.
Cool.
It's hard to take that curve and put it into standard form.
Okay.
But I could take that curve and put it into intercept form.
Mm-hmm.
What would it be?
In intercept form, it would be
We don't know the A yet. Let's just hold off on the A.
no.
What are the intercepts?
-1 and +1.
So it's x minus 1 and x plus 1.
Yeah.
So we know that much.
Yeah.
We'll get back to A in a second.
Okay.
We also, well, let's see. Maybe we don't have to get back to it in a second.
Mm-hmm.
We don't. Yeah, let's solve for A immediately.
Okay.
Now this part is a little different. We have to pick an x value.
Yeah.
We can read from the curve what the proper y value would be given an x.
Mm-hmm.
The only x values we cannot pick are 1 and minus 1.
Okay.
Because if we pick 1 or minus 1, this whole right side goes to 0. And we already know that y is 0.
Okay.
Okay, so that would not allow us to solve for A.
Mm-hmm.
But what if we pick an x of 2? What is y when x is 2?
If x is 2,
Yeah, you have to read it off that graph.
yeah, so let me see here.
You may have to read it off your graph that you have in front of you.
Yeah, so if x is 2, then y is also 2.
No, it looks
Or is that 2?
like it's
Yeah.
3. It looks to me like
Is it?
3. Yeah, I would say that point right there, x is 2, y is 3.
Okay.
Okay. Maybe it'd be better to take, yeah, let's take a point greater than 2 because it's actually hard to read that for 2.
Uh-huh.
But if I look at x being 3, what is y?
So if x is... Wait, can you repeat that? I'm just trying to
X
think,
is
like...
3.
Mm-hmm.
Go up and figure out what's y.
So if x is 3, then y would be... hold on. 2, 3, then y would be... Y would be 4 then?
No, look at the graph. Read the graph.
Well, yeah, it says it's on...
3, and then go straight up until you cross the graph, and then go straight over and read the value.
I'm reading then 7.
Yeah.
Okay.
Okay, so I can use that to solve for A.
Okay.
And that looks more accurate to me than using 2 and trying to figure out whether it's a 3 or 2.
Yeah.
So I'm going to use x of 3, y equals 7. So I'm going to plug in the known value for y.
Okay.
X is 3.
So it'd be 3 minus 1 and then 3 plus 1.
Yeah, so now we get 2 times 4, 8. So I get 8a equals 7. A equals 7/8. Now, I'm going to go back and change my opinion as to what y is when x is 3. I'm going to say y is 8.
Okay.
Okay? And if you look at that graph, you can make a pretty good argument for that.
Yeah.
In other words, it also crosses at 8. I mean,
Mm-hmm.
And the advantage of 8 is now everything a ends up being 1. And that's what I think it is.
Okay.
I wouldn't expect a to be 7/8 on this problem. On a graph
Mm-hmm.
that you have a hard time reading the exact coordinates.
Right.
So we're going to say that when x is 3, y is 8.
Okay.
That gives us an a of 1. So y equals strictly x minus 1 times x plus 1.
Uh-huh.
That's what goes in that box.
Okay, cool.
Okay.
Okay.
Now, it's the same a
Mm-hmm.
for the vertex form.
Yeah.
There's various ways to get the vertex form, and we're going to have to complete the square at some point to do it. But in this problem, we don't need to do it.
Mm-hmm.
So a is 1, then this is going to be our answer. What is h and k? Read it from the vertex.
Yeah, so H and K would be the X and Y coordinates.
Okay, what's the x and y coordinate of the vertex? Read it.
Yeah, so it'd be -1, 0, and then 1, 0.
No, you're reading the X intercepts.
Okay.
I want the vertex, that bottom lowest point. What are the
Oh,
coordinates on that point?
yeah, so that one would be 0, -1.
Okay, so h is 0.
Mm-hmm.
K is -1. Well, now we have our vertex format. Y equals x minus 0, just x squared, minus 1.
Cool.
And let's see if a is actually 1. In other words, I'm assuming the a's are the same. I think they have to be, but I think they are. Oddly
I
enough,
think they
I'm
are, yeah.
not positive. Let's see. When x was 3, y was 8. So yeah, a is 1 because 3 squared is 9 minus 1.
Yeah.
So
Yeah.
that even confirms doubly to me that when x is 3, y is 8.
Yeah.
Because it makes a nice, perfect vertex format there.
Right.
Now, what's the standard format?
Um,
If this is the vertex format, look at what they say for the standard format. It's
yeah. So it would be y is equal to x squared plus bx minus 1, but we don't know b, do we?
well, there is no x term. So
No.
it's just x squared minus 1. That's also the standard format.
Cool.
Not only is that the vertex format, but it's also the standard format.
Mm-hmm.
Another way we could get the standard format is by multiplying those two together.
Okay.
In other words, if I multiply x minus 1 times x plus 1, which was our intercept format,
Mm-hmm.
I get x squared minus 1.
Okay.
Well, I would get that even if I didn't have the vertex format first. Okay,
Mm-hmm.
the rest of these problems, they don't give you a curve, but they give you one of the 3 formats, and you have to figure out the other 2.
Right.
Let's do that. So
Okay.
if we start with y equals 2 times x minus 1, that's in X Intercept format. How would we get standard format? That's the easiest one to put it into first.
Okay. Well, what we could do so we could just factor it out.
No, it's already factored. You want to multiply it together.
Right. Right. Yeah, that's what I meant. My bad.
So 2 times, what's the product of those 2 linear terms?
So it would be, can we do the parentheses first and then just add the 2 in after we get what's in
I
the
left the 2 aside, and I put the parentheses to multiply x minus 1 times x plus 3.
Okay, so it'd be x squared plus 3x minus 1x minus 3.
Simplify that first.
And then it'd be y is equal to 2 times X squared plus 2x minus 3.
And the plus 2x gets multiplied by the 2 to become plus 4x.
Yeah.
And the 2 multiplies the minus 3 to become minus 3. So
Yep.
there's standard format.
Okay.
Okay? Now,
Cool.
the hard one to get it into is vertex format.
Yeah.
And in order to get it into vertex format, you have to complete the square. That's the way to do it.
Okay.
We've done a lot of completing the square. Here's the format we're trying to get it into. Let me write it up here. Y equals A times X minus H squared plus K. And we want to take this and put it into that format by completing the square. So let me get you started. First of all, I'm going to separate the x's from that minus 6, and I'm going to put the minus 6 way over there.
Okay.
I'm going to put parentheses around that, preparing to complete the square.
Right.
What do I need to do first before I complete the square? Or before I can complete the square?
You have to factor out the greatest common factor, right?
Good. So what am I left with now? So what is the greatest common factor there?
We could 2x.
Well, yeah, you're almost correct. You don't factor out the greatest common factor. You factor out the coefficient that is the coefficient of the x squared term.
Okay.
No matter what this is. I'm factoring that out because I cannot complete the square until I have a coefficient of 1 on the x squared term. So I'm factoring out a 2.
Okay. That makes sense.
Leaving that, notice that it's the same thing as it was before. Hasn't changed. In other words, I'm not really taking a greatest common factor out. I'm taking whatever the coefficient is. If that coefficient was 1/3, I would factor out a 1/3, and then I would have to divide 4 by 3.
Okay.
Okay, so it's not really, doesn't have anything to do with greatest common factor. In other words, if that was a 5 instead of a 4, I would factor out a 2, and what would be left over would be 5/2 x.
Okay.
Okay?
Right.
All right.
Right.
So now we're ready to complete the square. How do I complete the square?
And then it would be, so you would take a half of 2x, or just 2, which is 1, and square that, which is just 1, so it'd be plus 1.
Okay, now how much did I just add to the right side of the equation?
On the right side, you'd have to subtract 1.
How much did I add when I wrote 1 in there?
You added 2.
Ah, good.
Yeah, so you have to subtract 2.
Subtract 2, because, and I do the opposite because I'm on the same side of the equation. If this 6 was on the other side of the equation, then I would add 2 to the other side of the equation.
Okay.
And sometimes when you're completing the square, the number is on the other side. So you have to be aware whether it's on the same side or the other side. Well, if you look at standard format, this k is on the right side.
Okay.
And guess what? K is going to be minus 8. That's why I leave the number on the right side. Okay? Now, so I can now write the thing as 2, and then how can I write this?
You do x plus 1, and then x plus...
No, it's just x plus 1 squared.
Squared, yeah.
And you're always, in other words, the mere fact that you came up with this by completing the square guarantees that you can write it as a linear binomial term squared. Okay. Which is the goal. Notice that when I combine those two now, I have that. Well, you just put it into vertex format. Okay. Remember what vertex format is. Y equals A times X minus H quantity squared plus K. Yeah. The advantage of having it in vertex format is clear. You know immediately where the vertex is. Exactly. It's at where?
Okay.
Remember the vertex
Well,
is H,
so it'd be minus, yes, it'd be -1 minus 8.
correct.
Okay, cool.
Cool. Okay, so we did both vertex and standard.
Yeah.
Okay, you always get standard by just multiplying that out.
Mm-hmm.
And you always get vertex by taking the standard and completing the square on it by, first of all, factoring out the A.
Right.
Okay. So
Okay.
we've done that one. Now let's look at this one here.
Okay.
Leave enough of it up so that I can see the format.
Mm-hmm.
All right. So here they've given it to us in vertex format.
Yeah.
Now,
So we automatically know the vertex, -1, -4.
okay. Does that tell you? Let's draw a picture.
Okay.
So -1, -4 is right there.
Mm-hmm.
You know if it opens up or down?
It'll open up.
Correct.
Mm-hmm.
And they want us to put it into X Intercept form. Well, first of all, let's put it into standard form because that's easy. How do we do that?
Okay. Well, it'd just be x squared plus 1 minus 4, right?
No. Remember what you're doing. You're taking x times x plus 1 times x plus 1. What does that give
that's
you?
right. Yeah. Yeah.
What's that give you?
All right. So it would be x squared plus 1x plus 1x plus 1. So it'd be x squared plus 2x plus 1.
And then minus 4.
Yeah.
And now combine those two and you have it in standard format. In other words, you have x squared plus 2x minus 3.
Yeah.
That's standard format.
Cool.
Okay. Now, intercept format.
And then for intercepts,
Hold on.
we know the coordinates, so it'd be y is equal to a x minus 1 and then x minus 4, right?
No, we're going to have to solve this equation making y equal what? In other words, when I'm talking x intercepts, what's y?
X, well, when we're talking about, okay.
Always. No matter what kind of equation or function you're talking about, when you're talking x intercepts, what does that mean y is?
So when x is minus 1.
Hold on. Stop for a minute.
Okay.
Answer my original question. What is y when I'm on the x-axis?
0.
That's huge.
Yeah.
Okay? Knowing that is huge. You have to know that. What is x when I'm on the y-axis?
0.
Yeah, they're opposite one another. In other words, x-intercepts means y is 0. Y-intercepts means x is 0.
Okay.
So I can take this equation right here and set y equal to 0 and solve it.
Okay.
Well, let's solve that equation. Let me erase the picture because we no longer need it.
Right.
And we don't need that. So solve this equation. And you're going to get two answers, right? Those are going to be two x-intercepts. And then we're going to merely put it into this format up here. We know a is 1 already because from the vertex format we know a is 1.
Right.
So how do I solve that?
So you would do 0 is equal to x plus 1 minus 4 as one of them.
Hold on. Got to solve that for x.
Right.
How do you do that?
0 is equal to x plus 1 and then x plus 1.
No?
How would you,
well, what's another option?
add 4 to both sides.
There you go.
Yeah.
So if 4 is equal to x plus 1 squared, now what?
And then you would do x plus 1 is equal to 4, so it'd be x is equal to 3.
Hold on.
Right.
How do you solve an equation when you got a term that's squared? The variable is squared.
When the variables, you square root, you solve by square rooting it.
Okay. And whenever you solve by square rooting it, the first words out of your mouth need to be?
Multiplying.
Plus or minus?
Oh, that's what, yeah.
Okay. So what's the square root of 4?
2.
So it's plus or minus 2 equal x plus 1.
Right.
Now what?
Subtract 1 from both sides.
So here's our answer.
So x is equal to 1 or 3.
You got it. Not 3.
You're
right with the 1. In other words, when it's plus 2, we have 2 minus 1, which is 1. But when it's minus 2, we have minus 2 minus 1, which is not
so minus 3, yeah.
Minus 3. So x is either equal to 1 or x is equal to minus 3. Those are your x intercepts.
Yeah.
Okay? So now let's figure out how to write the equation.
Okay.
In this format on the left.
Okay.
You know what a is?
We know that a is x squared.
No.
Right.
A is 1.
Oh, that's in standard form.
A is 1.
So, yeah.
In other words, they gave us vertex format, which means a is 1. Because there's no coefficient in front of this.
Right.
There. Okay? So, we know the two x intercepts, that's p and q. So what's the format? What's the equation?
So it would be y is equal to a.
A is 1.
A is 1, yeah, my bad. So it'd be y is equal to 1.
What's this format say? X minus 1 intercept times x minus the other intercept.
Right, so it'd be x minus 1 and then x plus 3.
There you go.
Okay.
In other words, once you've solved for the intercepts, then you can write it in that that intercept form. If you know A already. If you didn't know A, then we'd have to solve for A. But we know A, and I guess this A is the same in all three.
Yeah.
Which I'm not sure I knew that before. I just, yeah, it's the same. So when you know A, you know it for this one also. So once you solve for the intercepts, that's all you have to do. Notice how similar it is to that one. That's x minus 1 times x plus 3, only it's got a 2 as a.
Right.
So, that's, there's another one there.
Cool. Yeah, there's one more.
That last one.
Cool.
All right. That's in standard form. Getting it to vertex form is the easiest thing.
Okay.
Once you have it in vertex form, we can set that equal to 0 and figure out what the x-intercepts are and then put it in x-intercept form.
Okay.
So, vertex form first. Here's the standard. It's always good to have this in front of you because this is what you're trying to make it look like. Right now, it looks like this.
Okay.
And you know the way to put it in vertex form is to complete the square. So let's set that minus 45 off over there.
Okay.
Now what?
And then we would take half of 24.
Hold on.
Which is...
Complete the square until you make the coefficient of the x squared term equal 1. How do I do that?
Equal 1.
Got to equal 1 before you can complete the square. I cannot complete the square of this as long as that's minus 3.
So you have to find the greatest common factor.
No, you just have to factor out the minus 3.
Okay, right. So
That,
it'd be,
that is not, in fact, the greatest common factor. The greatest common factor is 3x. But even if this was a 25, I would still factor out the 3. So it really doesn't have anything to do with greatest common factor. Okay?
okay.
It's you factor out whatever the coefficient is.
Okay.
Doesn't have to be greatest common factor. I'm factoring that negative 3 out. What's left over?
Okay. So it's 73, then x squared minus 8x, and then what goes?
Now hold on.
Minus,
I'm going to write it like that. Now, always be checking. Multiply that back together again. Is it what I started with?
or plus 8. It'd be plus 8.
Correct.
Yeah.
You want to pick up these little mistakes as you make them. You don't want to get to the end and come up with the wrong answer. You'll have no idea where you made your mistake. So always be checking.
Okay.
Now I'm going to put the 45 over there. Now this line 2 is the same as this line 1.
Yeah.
I've made no changes. I've just manipulated it. That's always what you want to do. Okay? Don't make any changes. Now complete the square.
So it would be plus 16.
Good. Now how do I balance that?
And then we would subtract 16.
When I wrote 16 in there, how much did I add to the right side of the equation? Or subtract.
Oh, that's right. So 16 times 3, which is...
Times negative 3.
Yeah, or times negative 3.
So what did I do to the right side of the equation when I wrote 16 in there?
You multiplied it by minus 3.
I subtracted 48.
Oh, okay. Yeah.
Right? In other words, here, let me take away the 16. It's exactly like it was. If I were to write a 1 in there, I would be subtracting 3. If I were to put a negative 2 in there, I would be adding 6. So whatever number goes in there, you are doing to the right side of the equation the product of that number and this coefficient that you factored out, which is minus 48, which means you have to add 48. Now it's the same. Now equation 2 is exactly the same as equation 1.
Okay.
Again, always make sure you make no changes.
Right.
Now we're getting closer to vertex format. Notice what vertex format is. Has an A, that's what we factored out. This quadratic here I'm going to be able to express as an x minus some number squared. So let's do that.
Okay.
What is it? X minus what squared?
So it'd be x minus 4.
I didn't mean
or plus. Yeah, it'd be x
to
plus
fool you. In other words, you have to do whatever this does. This quadratic is x plus 4 squared. We know that because we completed the square. So it always is going to be some binomial linear term. Combine those two over there, you get that. Okay. Now stick a y in front of it, and you got your equation in vertex format.
Cool.
Okay.
Okay.
Now, the last thing is to put it in X Intercept format. We can do that really quick. What do we have to set y equal to?
Y is equal to minus 3.
How do you find the X Intercepts? How do you start?
It'd be minus 4 plus 3.
No, let's start at the beginning. Don't get ahead of yourself. If I'm solving for the X Intercepts, what does y have to be?
The opposite, so...
No, not the opposite. When I'm on the x-axis, y is always 0.
Right, and then if you're on the y, or if you're on the x-axis, y is always 0.
Yeah, but all parabolas usually have two x-intercepts. That one and that one.
Okay.
What's in common about both of them is that y is 0 for both of them.
Yeah.
That's how we can solve for the x-intercepts, is to set y equal to 0. In other words, right now I had y equals all of this, but if I turn y into 0, then I'm going to solve for the x-intercepts. That's how you do it.
Okay.
That
Cool.
means minus 3, I'm going to bring this 3 over,
Right.
equals
So,
minus 3 times x plus 4 squared. Now what?
and then we would, we could add 3.
No? How do I get rid of this minus 3? I can't solve this equation until that minus 3 is taken care of. And I'm talking about this minus 3 here, not the one over here.
Okay. You'd have to subtract it then, right?
What is on the right side of the equation, what is the minus 3 doing right now?
Being multiplied by...
What do I have to do to get rid of it?
Multiply.
Divide. Always the opposite.
Or divide. It's always, it's always opposite. I remember that.
Divide by minus 3. I'm going to divide that side by minus 3. I get 1 now equals x plus 4 quantity squared. Now what?
And then we would do, we'd square root it.
Okay. So what do you get?
So you get square root 1 is equal to x plus 4.
First of all, it's plus or minus.
Or plus or minus
and the square root of 1 is 1. So I've taken the square root of both sides. Okay?
Okay.
Now I'm going to move the 4 over and I'm going to have my two solutions. So here's the two solutions. X is equal to plus 1 minus 4, which is minus 3. Or x is equal to minus 1 minus 4, which is minus 5.
Right.
Have my two intercepts. I know A is minus 3 from the previous problem when I put it in vertex format. So what's the format? Or what's the final equation in intercept format?
So it'd be y is equal to 1.
Hold on. What's A?
A is 1.
No.
Or A is minus 3, my bad. So it'd be y is equal to minus 3, x plus 3, and then x plus 5.
Good.
Cool.
Perfect.
Perfect.
Yeah, no, I like this page. This is an excellent exercise to do where you convert. You're given one equation and you have to convert to the other two.
Right.
Great exercise. You want to be able to do this page perfectly no matter what functions they give you.
For sure.
All right, Dylan.
All right, awesome.
I'll let you get back to watching those Cubbies try to beat the Indians.
That sounds good.
I watch everything tape delayed, so I'm still in the second inning.
Oh, awesome! I won't tell you what's happened.
All right. Talk to you later.
All right. Sounds good. Bye bye.